We are on the verge of the petahertz age, where computers could run up to 1 million times faster than today's machines while consuming only a fraction of the energy. Not by building bigger chips or adding more cores, but by replacing the electrons inside computers with something that has no mass, generates virtually no heat, and travels at the fastest speed the universe allows: light. For decades, computers have relied on silicon chips, where electrons carry information through microscopic circuits. As engineers kept shrinking transistors, computing became faster. But physics imposed a limit. Electrons collide with atoms, creating resistance, heat, and massive energy waste. Today, data centers already consume about 1% of the world's electricity, and demand for computing continues to grow rapidly. Silicon is approaching its thermal limit. Photons behave very differently. Unlike electrons, they don't repel each other or create electrical resistance. Multiple beams of light can travel through the same space simultaneously without interference, producing almost no heat. Less heat means far less cooling, lower energy consumption, and dramatically greater processing density. So why haven't computers always used light? Because until recently, we couldn't manipulate light on chips small enough to replace electronic circuits. Fiber optics have transmitted internet data at the speed of light for decades, but the signal still had to be converted back into electricity before being processed. That conversion was the bottleneck. Now, photonic integrated circuits are changing that. Instead of electronic transistors switching electrical current, these chips process information directly with light. The difference is extraordinary. Modern processors operate in the gigahertz range, billions of cycles per second. Photonic processors have the potential to reach petahertz frequencies, a quadrillion cycles per second, while using only a fraction of the energy. This breakthrough is deeply connected to Einstein's special theory of relativity. In 1905, he showed that the speed of light is the fundamental constant of the universe. For over a century, that idea belonged mainly to physics. Today, it's becoming the foundation of a new generation of computing. The impact could be enormous. Processors that don't throttle from overheating, laptops with dramatically longer battery life, data centers requiring far less cooling, AI models trained in hours instead of weeks, and major advances in medicine, climate science, and finance, all while consuming much less energy. This isn't science fiction. Photonic chips are already being tested in laboratories, and companies around the world are racing to commercialize them within this decade. The silicon era gave us the internet, smartphones, and artificial intelligence. The photonic era is just beginning. And if the physics is right, as it has always been, we're about to build the fastest, most energy-efficient computers humanity has ever created.